In this Chapter 28 video, you're going to solve real-world problems involving ratios and rates of change. The objectives for this chapter are to define ratios, define rate of change, determine rate of change in a given context, formulate a ratio in a given context, and convert a ratio to a unit rate. Ratios and rates are one part of math that is used on a daily basis. As you can see this little table here, these are ratios and their meanings. How much is the cashier earning work? Dollars per hour. How fast is the train going? Miles per hour. Do I drink enough water? Cups per day. Does my smartphone data plan meet my usage needs? Gigabytes per month. Can I afford the mortgage payment for that house, which is the principal plus the interest plus escrow divided by a month? All these are examples of ratios and rates. On the TEAS, you'll encounter a range of real-world problems that involve ratios and rates of change, so you'll want to understand these concepts and how to put them into practice. Now, before we continue on with the sections in the TEAS book, let's talk about a few key terms that we need to understand. A rate is a ratio that compares quantities of two units of measure. So these units of measures are attached to the numbers in the rate. So you're going to have two different units of measure. You have to put them with the rate. The rate of change is a rate that describes how one quantity changes in relationship to another. So if you're familiar with the slope of a line, that's an example. Y equals mx plus b. A ratio is a comparison of the size of two numbers or quantities. It's written as a fraction with a numerator and a denominator. It can be simplified like a fraction, but it cannot be changed to a mixed number. So you cannot have mixed number ratios. You can leave them as improper fractions, that's fine. That's what a ratio looks like. And a unit rate is a rate expressed per one unit. An example might be 55 miles per hour or 26 miles per gallon of gas. These are also called the rate of change. A unit price is a unit rate that expresses a money amount per one unit. An example would be $1.50 for a bottle of soda. Here's where they got the definitions for ratio, rate, unit rate, and rate of change. We're going to talk about this one in a few moments, but remember, a ratio is a comparison of two numbers by division that is often represented as a fraction, because a fraction just really means division, which may or may not be written in lowest terms. So an example of ratios are 2 divided by 3, or 2/3, 7 over 10, and 7 over 2. All of these are ratios. They look like fractions. This one is an improper fraction, but it's still considered to be a ratio. Ratios with units are called rates. So 2 cats over 3 dogs, 7 absents over 10 presents, 7 miles over 2 hours. These are all rates because they have different units of measure. And when you start talking about unit rate, is a rate that is expressed per one unit. For example, 7 miles over 2 hours, the unit rate would be 3.5 miles over 1 hour, or 3.5 miles per hour. And the way that we got that was we took 2, divided it into 7, we got 3.5, and it is miles per hour. That means per 1 hour. So to find a unit rate, simply divide the numerator by the denominator. Now I'm going to let you read through this example, but just remember, all rates must also be labeled with the units in the numerator and the denominator, just like they've got it here, just like we had up here, and just like we had here. Because rates relate two numbers with units or variables, they can be represented on a graph. The unit rate is also called the rate of change. I want you to refer to the graph on page 173 in your textbook to see the slope between 2 points. This is the formula that they are using. Slope is equal to the change in y over the change in x, rise over run, or the rate of change. If you've done a class where you did talk about slope, you've used rise over run or change in y over change in x. And so to find the rate of change, use this slope formula below, y sub 2 minus y sub 1, where these 2 points are the two y values of your particular points. x2 minus x1, where these are the two x values of your 2 points. Now make sure that when you use the y sub 2 and the x sub 2, that's the ordered pairs numbers. And the same thing for the y1s. You can switch them around, but you can't have y1 minus y2 and then x2 minus x1. They have to be put in this particular order. Now, if you look at the graph that's in your book, they've got two different points noted, 3,75 and 8,200. And they want to find the rate of change between this point and this point. So the first point in each little ordered pair, that's your x values. The second one is your y value, so make sure you put them in correctly. They took 200 minus 75, because that's the dollars. They looked over here and saw this is the balance in dollars, over, let's see the change in the x values, 8 minus 3. So 200 minus 75 is 125. 8 minus 5 is 5. That should be 3. As you can see, they've got 8 weeks minus 5 weeks, where this should be the 3 that's here. So there should be 8 weeks minus 3 weeks to get 5 weeks. And then 125 divided by 5 will give us $25 per week. So make sure you make the notation in your book that this should be a 3 instead of 5. They made an error. And then down here, they just use a different example. I'm going to let you look at this one yourself. Now we're going to work this particular example because the answer is going to look a little bit different than what you may have seen as far as a fraction. Ellen works at a bakery. She pulls out the recipe and discovers that the number of cups is unreadable for a cake recipe. Her boss tells her that yesterday the bakers used a total of 22 cups of cake flour to bake 6 cakes. So the ratio of cups of flour to cakes is 22 cups over 6 cakes. Now remember, whichever way you put this, you got to put it in, use the same sequence in all the parts of your problem. She needs to know the number of cups of cake flour to make 1 cake only. So she writes down the ratio, 22 cups over 6 cakes. And she says, well, I'm going to divide that by 6 over 6, which is really 1. So if you take some fraction, divide it by 1, you're still going to get what you started with. So 22 divided by 6 is going to give us a mixed fractional or improper fraction on top of the fraction bar. And then 6 cakes divided by 6 is going to be 1. Now we can have this. We can have a fraction in the numerator, or in some cases you might have a fraction in the denominator. So don't let that scare you. And then once we do that, we're going to simplify our fraction. 22 over 6 is the same thing as 11 over 3, which is the same thing as 3 2/3 cups. It's okay to have a mixed number part of your fraction in a ratio. It's fine with that. You just can't have the whole ratio as a mixed number over 1 cake. So this is the same procedure we use to reduce fractions. After dividing by 6, the rate has been reduced to 3 2/3 cups to make 1 cake. And so this is Ellen's unit rate. So all unit rates must also be labeled in the numerator and the denominator as we've discussed before. Now I have a couple more ratios, rates, unit rates worked out here in an example. So let's look at each one of these. A high school band has 125 members. 75 of them are women. So I want to know what's the ratio of women to total members in the band. Well, there's 75 women out of a total of 125. When I reduce this fraction, I'm going to get 3 women to 5 members. So this is the ratio for this particular part A. Now what I want to do now in part B is, what is the ratio of women to men in the band? Well, the first thing we need to do is determine how many men are in the band first. Well, if 75 are women, then 125 minus 75 is going to leave 50 are men. So now we know the number of men. We also know the number of women. They wanted to determine how many men are the women to men. So I got to have women was the first thing listed, so it's going to go as the numerator. The men was the second thing listed, so they're going to go as the denominator. And when I simplify it, I have 3 women to 2 men. This will be the rate in this particular example. Now here's another one. You may have to use this in real life. Carl can drive 366 miles in 6 hours. So what is his unit rate of miles driven per hour? So since we're wanting a unit rate, we have to have 1 on the bottom in our final answer, which you will see this is the final answer. The question is, how do we get there? Well, I'm going to set up the ratio rate first. 366 miles over 6 hours. I'm going to take the numerator and divide it by the denominator. I'm going to get 56 miles for that part. And it's per hour, or 56 miles divided by 1 hour. Now, when you're talking unit rates, you can write it like this, or you can write it like this. Both are acceptable. This one, it says a 12-can carton of soda costs $4.20 per carton. I want to know what's the unit price of just 1 can. Unit price is a unit rate. It's just that we're now dealing with money. So when you're doing a unit price, money has to go on top, divided by the other unit of measure, which in our case was per carton, which was 12 cans. We're going to take the money divided by the number of cans. You'll get $0.35. Or you might write this as 35 cents, but if you're going to write it with the cents mark, you got to write it with the cents mark. You can't use the dollar sign. Or $0.35 over 1 can. So when you're talking money, don't change it to cents if it's given to you in dollars. Leave it in dollars. Let it be a decimal dollar amount. Well, good luck on this chapter.